All right, we are starting 3.2 today, and we're going to keep talking about the angle pairs, but only talk about parallel lines and parallel lines today, and what happens to those angle pairs when we are talking only about parallel lines. So by the end of the video, you should be able to prove and use theorems about the angles formed by parallel lines and a transversal. So again, we're only talking about parallel lines today. So the four different angle pairs that we've talked about were corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. And we talked about those in class, and I think I have these letters down. Corresponding angles is like the F. So remember, the corresponding angles are in the exact same spot, same side of the transversal. They're both on the right-hand side of the transversal, and they're both below these parallel lines. So again, today we're talking just about parallel lines, and I'll go ahead and show you which ones are the parallel lines by putting those arrows on it. So corresponding angles, we have the F. Then we have alternate interior angles. We can consider that as Z. So again, here are where those alternate interior angles are always going to lie, and here are your parallel lines. So alternate interior angles are inside those parallel lines and on opposite sides of the transversal. So one's on the left and one's to the right. Okay, alternate interior angles we can think of like, I guess, an H. So if you draw like an H and extend those, alternate exterior angles, are outside of those parallel lines. So here are the parallel lines, and they're on opposite sides of the transversal. So one's up, one's down. And then the last one, same side interior angles, we can think of those as like the big C. And they're both on the same side of the interior angle. I'm sorry, that didn't even make sense. Same side of the transversal, so they're both to the right, and they're within those parallel lines, and here are the parallel lines. Okay, so what we're going to do is we're going to use these four and see what happens when we talk about parallel lines. So on your yellow cheat sheet, I want you to write down these four different theorems and postulates. There's four of them. The first one is going to be called corresponding angles. You don't have to write this down, but if you want to, if you're a word person, this is also located in your book in 3.2, so you can copy it down from your book. But basically, corresponding angles, again, you're writing this down on your yellow theorem cheat sheet. And I'm sorry, my handwriting is so horrible today. Okay, so the hypothesis, remember, this is what I'm going to give you. So we might use these in proofs later. Yay! So I have to give you a picture that looks something like this. Remember, I have to give you these parallel lines. I have to tell you these are parallel, and I have to tell you about something about these two angles. If I tell you that these lines are parallel, then every single time angle 1 is going to be congruent to angle 2. That's just called the corresponding angles postulate. The next theorem is called alternate interior angles. And again, it doesn't matter to me if you call it a postulate or a theorem. Alternate interior angles is fine if you just write alternate interior angles. If I tell you that there are parallel lines, that's all I have to tell you, then every single time angle 1 and angle 2 are going to be congruent to each other, because now these are both in alternate interior angles. So all alternate interior angles will be congruent. All corresponding angles will be congruent, just when I tell you we have parallel lines, which is pretty cool. Also, third thing, if we have parallel lines, here we have our parallel lines. I have to give you parallel lines. Then alternate exterior angles will always be congruent. So 1 and 2 will always be congruent to each other. That's called the alternate exterior angles theorem. Again, if you just write alternate exterior angles, pretty cool. Okay, so far we've said these three angle pairs are going to produce congruent angles. Fantastic. All corresponding angles are congruent. All alternate interior angles are congruent. All alternate exterior angles are congruent. The only one that's different are same side interior angles. Remember, those are the ones that are on the same side of the transversal. Sorry. But interior. Thanks, Mary. Thanks, Mary. But inside these parallel lines. So same side interior angles are not going to be congruent like the other ones. They're going to be supplementary. They're going to add up to be 180 degrees. So we've wrote those four theorems down on our cheat sheet. Let's go ahead and put them into practice, and we'll do proofs later on. So the first one, finding angle measures. So x, we're looking at x and 118 degrees, and this is 118 degrees right here. Well, if you notice, these are corresponding angles. If you want to think about the F, there's the F. So x is going to equal 118 degrees. But I want you to go beyond that. The shortcut, if you can't remember what's congruent or what's supplementary, they're either going to be congruent or they're going to be supplementary. So if it looks like an obtuse angle, guess what? It's going to be the same. See, 118, 118. This one doesn't look like an obtuse angle, so it's supplementary. So this one's going to be what, 62 degrees? This one also looks like it's an acute angle, so that one's going to be 62 degrees. These are vertical angles, these are vertical angles. Amazing. If you look at this one and this one, well, these two are same side interior angles. Notice this is acute, this one's obtuse. So that means this one has to be 118. And this one and this one, these are alternate interior angles. The way you guys can look at this is just, it's like unreal how many different possibilities there are. But the shortcut is if they're obtuse, then they're going to be congruent. If they're acute, then they're going to be congruent. And that's all because we have these lovely parallel lines. So these are acute, so these are going to be 62 degrees. Okay, so this next problem I want you to think about, I want you, there's first of all, solve for x. And then there are 5 different ways for you to solve for measure of angle EDG. This, like, again, there's so many different ways you guys can look at this picture. Find x. Here's x. Boom. No, we're not done. I want you to actually give me a measure. So what I would do, I think the simplest thing for me is to look at this 75 degrees. Well, there's no relationship between these two, but these are vertical angles. So that means that this has to equal 75 degrees as well. And then if I look at these two angles, those are same side interior angles. So that means that this angle plus this angle have to equal 180 degrees. So I know x plus 75 has to equal 180 degrees, and then I can solve and I get x equals 105 degrees. All right, that's one way to solve for x. Now if I wanted you to solve for measure of angle EDG, EDG is this angle right here. So all I would have to do is plug in 105 here. Or, that's one way is to plug it in. So let's see, 105 minus 30, I would get 75 degrees. Oh my gosh, wasn't there 75 degrees someplace else?
Megan Corfield, please come to the attendance office.
Let's see. 75 degrees is right here, and this angle is EDG. That's what we wanted. These are alternate exterior angles. So another way to do it is alternate exterior angles. So x minus 30 equals 75 degrees, and that's how another way you can solve for 105. Okay, so far, let's see. We've done 2 different ways to solve for x and to solve for angle EDG. Just solving for x, we've done 2 different ways. I want to see if you can figure out 3 more ways, 3 different ways to solve for x. Good luck with that.